Find the inverse function to f of x equals 5 to the x. Well, remember when we want to find an inverse function, first we need to check, is the function 1-to-1? So let's take a look. Remember, all exponential functions, they look kind of like this. So this passes the vertical line test and the horizontal line test. So this function is 1-to-1. It's going to have an inverse. In order to find the inverse, I switch x and y, then solve for y. So I have y equals 5 to the x. Okay, now I'm going to switch this and have x equals 5 to the y. I need to get this exponent of y down. So the next thing I'm going to do is take the natural log of both sides. That means I have the natural log of x equals the natural log of 5 to the y. And I can use one of my logarithm rules, right? Remember, ln is log base e. We call this the natural log. And it's what we use to solve some algebraic equations. So I'm going to bring this y to the front. That's one of my rules. So I have the natural log of x equals the y natural log of 5. I'm going to go ahead and divide both sides by the natural log of 5, because remember, that's a number, right? When I take the natural log or the log of a number, I'm getting the exponent out. Like, what would I raise e to get 5? That's the exponent I'm getting out. So I have natural log of 5. That gives me y. So I've got y all by myself. I have found my inverse function. So f inverse of x, we write it like this, add that to the -1, that tells us f inverse of x, is the natural log of x over the natural log of 5. Next, factor the denominator of this function and find the vertical and horizontal asymptotes. Now remember, you are given the asymptote rules, but you do need to know how to use them. So let's go ahead and factor our denominator. I have x squared minus 1. I'm going to rewrite this with a placeholder. And I need to find the factors of AC that add up to B. So in this case, I have A equals 1, B equals 0, and C equals -1. So AC equals 1 times -1, which is -1, and B equals 0. Well, what are some factors of -1? The only factors of -1 are 1 and -1. And lucky for us, those add up to 0. So remember, I do all this so I can rewrite my middle term, b, instead of as 0x, as -1 plus x plus 1x. So I'm going to have x squared minus x plus x minus 1. And then we factor by grouping. X squared minus x is going to give me an x. So I have x times x minus 1. And then the greatest common factor of x and -1 is just going to be a 1. So I still have to pull out the greatest common factor, though. Collect my greatest common factors and what they had in common. So I need to find my vertical asymptotes and my horizontal asymptotes. Our horizontal asymptotes have to do with what's left out of the domain. Remember, I cannot divide by 0. So we want to set our denominator equal to 0 and solve for what values would make my denominator 0. Okay? So I have x plus 1 equals 0 and x minus 1 equals 0. So I have x equals -1 and x equals +1. +1. These vertical lines, right? X equals -1, it's graphically a vertical line. These are my horizontal, nope, it's going to be a vertical line. I just said vertical. These are going to be my vertical asymptotes. Now, to figure out our horizontal asymptote, we need to look at our rules. And there's a checklist for horizontal asymptotes. The first one being, if the degree of my numerator is less than the degree of my denominator, then I have an asymptote at y equals 0. Well, here the degree of my numerator is 0. The degree of my denominator is 2. 0 is less than 2. So I have a horizontal asymptote at y equals 0. Now, I am not asking you to graph this function. I am asking you solely to tell me what the vertical and horizontal asymptotes are. Next, we need to give the equation of a function based on f of x equals x squared that is shifted up 6 units and to the left 4. So, we need to sketch this out. Okay, I'm going to have my function x squared. That's our most basic parabola. If you aren't sure how to graph it, plug in a few points, but we should all know it looks like this. Now, I want to shift my graph up 6 units. So when x is 0, I want my y to be 6. So I'm shifting up 6. This little green dot right here. But then I also want to go 4 units to the left. So this is going to be my new vertex. How do I write my function like that? Well, we have some graphing rules that we've worked on before in this class. If I add 6 to the outside of my x, that changes my y. Okay? So this is what's going to shift my graph up 6. Now, I'm going to shift 4 to the left. But do I add 4 or subtract 4? Remember, it's opposite. If I want to go to the left, I'm actually adding 4. So this would be my function shifted 4 to the left and 6 up. This would have been to the right if we added negative 4. If h of s is 5s cubed minus 7s plus 1, then what is h of negative 3? All it's wanting us to do here is substitute in negative 3 for s and find the value. So if I take h of negative 3, that's 5 to the negative 3 cubed minus 7 times negative 3 plus 1. H of negative 3 is 5. Negative 3 cubed is actually negative 27. Minus 7 times negative 3, that's positive 21 plus 1. So I have h of negative 3 is negative 135. 5 times negative 27 is negative 135 plus 22. I have that h of negative 3 is negative 113. Okay, next, find the next 2 terms of the sequence. We need to tell what type of sequence it is, whether it's geometric, which is when we multiply by a constant, so we have a common ratio, or it's arithmetic, that's when we're adding the same constant every time to find the common difference. So here I have negative 6, negative 3, 0, 3, 6. Does it look like we're multiplying here? No, if we were multiplying for our ratio, negative 3 times a half would be, negative 6 times a half would be negative 3. But then in order to get negative 3 to be 0, I have to multiply by 0. So that's not the same common ratio. So this is an arithmetic function. What I'm doing each time is I'm adding 3. So that's going to be my difference. If you didn't know how to find the difference, it is your second term minus your first term. Now, since I know my difference, I can calculate the next two terms of the sequence. 6 plus 3 is 9. And then I have 9 plus 3, which is 12. So these are the next two terms of my arithmetic sequence with a difference of 3.